right, guys, we're back. Um, Today we're gonna be doing some. We're gonna be continuing with chemistry. So we're gonna be doing finishing up on chapter three because I think we started it in the past. So we're just gonna get that out of the way. Um, I don't know. I don't know if the last time if it was organized or not. I don't know. I'm not gonna lie. I don't really remember when we set it up completely. Um, but I'm pretty sure it is. I didn't try like reordering it or anything. Um, but yeah, hopefully it goes smoothly, like something calm, like an easy day, an easy chill day. Uh, all right, let's put our lo-fi music. It might be sped up right now. Okay, it is not. Uh, Let me make sure you guys could hear it. All right, perfect. Um, all right, I think we should be all good. Now let's save that. All right, let's get it. Yeah, we started, but we never finished it. Okay. What is a rule that describes? I looked at some of these cards. Like I was looking at which card I wanted to do again. So the first, like some of the cards, I'm just gonna have a little more background knowledge than normal, but it's okay. What is a rule that describes the way atoms join to form compounds, and what does it state? Um, it's the octet rule. It states that they like to form compounds in a way that allows it to have a full octet. Eh, I mean, like, yeah, I'm gonna give myself a hard. What are intramolecular forces? They're like bonds or attractive forces that occur within the molecule rather than among molecules. Okay. Electrostatic interactions. I'll give myself an again just for that. What is bond energy? Like probably the amount of energy that it takes to form a bond. Energy required to break a bond. Oh, right, because forming bonds releases energy. Wait, I think, I think. Energy required to break bonds by separating its components into their isolated gaseous atomic states. Um, Energy required to break bonds by separating its components into their isolated gaseous atomic states. Are they always gases? Uh, um, okay. I didn't know that last part. I didn't know they needed to be gaseous. Okay. What are intramolecular forces? Um, They're electrostatic interactions that occur between between or among like molecules or like separate molecules. Oh, brother. I thought it was a different card. I think I just finessed myself. What is the shape of the S orbital? It's a sphere. We're gonna suspend. Shape of the P orbital. It's like two water droplets. Something like that. I drew the top one so like intentionally, and then the bottom one is just a blob. Three lobes. What? What? What do you mean three lobes? I'm gonna look up what the shape of a P or of the P orbital is. What do you mean three lobes? It's it's two lobes. It's two lobes each. Um, but you know what this sounds like to me? It sounds like a suspend. What is bond energy? Um, bond energy is uh, bond energy. The energy required to remove a bond by separating its components into their isolated gaseous atoms. It's strong electrostatic forces that occur, or interactions that occur within the molecule. What is a molecular orbital? Um, um, uh, I just need to check this card too, bro, because it sounds right, but it's like from electrons occupying areas of overlap between atomic orbitals. Okay. Uh, it says that basically they form compounds in such a way as to share valence electrons and attain a full octet. What are the characteristics of ionic compounds? They definitely have high melting points. Uh, uh, what else? I don't know. High melting and boiling points dissolve in water and polar solvents, form crystalline lattice structures to maximize attractive and minimize repulsive forces. Okay. Greater than, is it like 1.5? 1.7. As the charge separation of a cation and anion increase, ionic, buddy. We're pressing easy on that one. What is a molecular orbital? It's like an atomic orbital, but it's for molecules that are bonded together. That's the area of overlap in their molecular orbitals. Saying basically where the electrons are obviously most likely to be found. Um, oh, I read this card wrong the first time. We have to click again. What is a crystal lattice? Ordered arrangement of ions to minimize systems energy slash stabilize a compound. What is the characteristics? They have a high melting and boiling points. They dissolve in water and polar solvents. Um, and they form a crystal lattice in order to maximize attractive and minimize repulsive forces. How big must the difference in electronegativity be to not be to be considered an ionic bond? Uh, Greater than 1.7. What is a molecular orbital? It is like an atomic bond, but for molecules, the areas of overlap in the molecular orbitals, they are, um, that's where like the bonds form. Uh, Wait, hold up, because this I looked it up earlier, and it told me to make an edit that I didn't make because I didn't read the card correct. Right. There you go. What is a crystal lattice? It's an ordered arrangement of ions to help minimize the system's energy and stabilize a compound. What is bond energy? The energy required to remove a bond and separate like the two atoms into their or separate the two molecules into their isolated gaseous atomic states. What are intermolecular forces? Electrostatic interactions that form within a molecule. I'm saying an ionic compound when you dissolve it. Um, like, I was just gonna say like basically that the water molecules are gonna like surround it, split into constituent cations and anions. So, what What are the characteristics of covalent compounds? Uh, relatively weak, relatively weak intermolecular interactions. Um, lower covalent, lower boiling and melting points don't break out into ions. It's like an atomic orbital, but with like an atomic orbital, but it's based on the overlap between based on the overlap between no. It's like an atomic orbital, but for molecules. The areas of constructive overlap are going to be the like correlate to a bond between those molecules or between those atoms. What happens to an ionic compound? It separates into its cations and anions. What kinds of covalent bonds can potentially form? Uh, what? Oh, this is like, brother. What? What is even going on here, bro? This was like almost perfect. Uh, okay. I'm gonna suspend this card too. What are the characteristics of covalent compounds? Um, they're poor conductors. They don't break down into ions. They have like relatively weak IMF. Uh, and what else? I've forgotten the middle one. Lower boiling and melting points. Okay. Molecular bonds are made from overlapping atomic orbitals. What kind of bond do you get when orbitals overlap directly? A sigma bond. I'm pressing easy. I know that. Blank bonds allow for free rotation of the atoms that make up the bond. Sigma. Coordinate covalent bond. I don't know. One atom contributes both bonds. So, what are diatomic molecules? It means that it's a molecule where both of the atoms are the same atom. Oh. What are the characteristics of ionic compounds? They dissolve in water and polar solvents. They they're going to um so it's gonna have higher melting and boiling points. Uh, they're conductors of electricity, of heat and electricity, I guess. I don't even know why I said the conductors thing, bro. Form. Okay. What are the characteristics of covalent compounds? What are the characteristics of covalent compounds? They have a lower, they have relatively weak IMF, lower boiling and melting points. They're poor conductors, and uh, damn, don't break down into ions. Greater than 1.7. One of the atoms contributes both of the electrons. What are diatomic molecules? The seven atoms that don't exist alone in nature. I guess they're not really atoms, but I'm still clicking good. What is a crystal lattice? An ordered arrangement of ions to stabilize a compound or minimize system and the system's energy. What is bond energy? The energy required to remove a bond in a compound to separate the energy required to separate components into two isolated gaseous uh, states. What are the characteristics of ionic compounds? Um, they're going to um, they're going to um, they're gonna have higher melting points and boiling points. They're gonna have uh, they're gonna dissolve in water and polar solvents, and they're gonna form crystal lattice structures in order to minimize repulsive forces and maximize uh, attractive forces. The octet rule. What are the characteristics of covalent compounds? Um, they're gonna have relatively weaker IMFs, so also lower melting and boiling points. Uh, they're gonna be poor conductors and they don't break down into ions. It's like an atomic orbital, but for molecules. The areas that the molecular orbitals overlap, where they have where they constructively overlap, is corresponding to bonds. What is bond polarity? Um, Bond polarity is um, bond polarity is indicated by the electromagnetic difference between the two molecules. What is a nonpolar covalent bond? Um, it's a covalent bond where the electrons are equally shared. It's an equal agreement. Um, I'm not gonna memorize that. It's most often manifested by diatomic molecules, just because of like I don't know, like a hydrocarbon or something, bro. I'm pretty sure that's a nonpolar. I think. I think. Um, like these are strong electrostatic interactions that form within a molecule. Um, it has to be greater than 0.5, but less than 1.7. Bond polarity is how unequally the electrons are shared in a bond. What is the dipole moment? That's a great question. I think it's just a marker of polarity. I don't know. Net vector of electrical charge in the molecule, whatever that means. What is formal charge? I don't remember the formula for this. Difference between the valence electrons on an atom and how many it has when neutral. Okay, so subtract the number of valence electrons from no, subtract the number of lone pair electrons individually and the number of bonds it has from the number of valence electrons that it normally has. So since this one has seven, since fluorine should have seven, it would be seven minus one, two, three, four, five, six. So, and that's how you get to the plus one. Okay, cool. Uh, what is bond energy? Bond energy is hmm, it's the energy required to break a to separate components into their isolated gaseous states. I think I said that. The ordered arrangement of ions in order to minimize system energy or a stabilize the compound. I keep thinking stabilized protein. Stabilized protein. You're just telling me protein, and it's not protein. What happens to an ionic compound when you dissolve it? It separates into its cation and anion. What is dipole moment? The net vector of electrical charge in the compound. Oh, in the molecule. I'm still giving myself that. What are the characteristics of covalent compounds? It has a relatively weak IMF, lower melting and boiling points, poor conductor, and it doesn't break down into ions. What are the characteristics of ionic compounds? Characteristics of ionic compounds are uh, it has high melting point and boiling point. It uh, dissolves into water and polar solvents and forms a crystal lattice in order to minimize repulsive forces and maximize attractive forces. Subtract the number of valence electrons that it normally has the number um, by the number of valence electrons it has uh, in the molecule or compound. Didn't I just suspend this card? We just did this. It was in the other card. To be an ionic bond, it has to be greater than 1.7. Guidelines to choose the best Lewis structure. It should have the least amount of charges. Um, it should have the least amount of charges and all the unless it's an exception, it should have uh all the atoms should have a full octet. Okay. What is a resonance structure? A resonance structure is another way um of drawing the molecule that's still it's still true, um based on there are some that are more prominent than others, but it's based on stability and is based around the idea that the electrons are constantly moving. So the yeah, something like that. But one of the atoms provides all the electrons. Which it's gonna behave like the structure that follows most of the rules that we have previously established. Oh, guidelines to choose the best Lewis structure. So it should have either small or no formal charges. You should try to minimize the separation of the formal charges, and what's it called? Um, it was something about choose. Choose. Uh, choose the one that puts the negative formal charge on the more electronegative atom. What are diatomic molecules? They're molecules with um, molecules that are the same atom, just twice. They don't exist alone in nature. What is a resonance structure? A resonance structure is, I don't know, Lewis structure with the same conductivity, but the electrons are arranged differently. It's gonna behave like a resonance hybrid. Sometimes there are the dominant resonance structures, which means that it's gonna behave mostly like that one with small characteristics of the other ones. What are the two geometries that Besper theory can give you? the two types of geometry that Vesper theory can give you. Um, what is a molecular orbital? Like an atomic orbital, but for molecules, the area of atomic or of like atomic orbital overlap, assuming that it's constructive overlap, is going to be is going to correspond to a bond. What is a resonance structure? A resonance structure is the uh, Lewis structures with the same connectivity but different ordering of electrons. I don't know if I just said that. I'm gonna press again. I'm actually gonna get myself hard. If I remember it, then I remember it. What is the dipole moment? It is a net vector uh, of the of the charge of the partial charge of the compound of electrical charge in the molecule. I feel like that's kind of right though, to be honest. What are the two types? You could have um, electronic geometry and molecular geometry. Molecular geometry is obviously going to be the shape of the molecule. The electronic geometry is going to be the arrangement of the arrangement of the molecule and its electrons. Distribution of electrons in a molecule. Um, greater than greater than 0.5, but less than 1.7. An output has a very small or non-existent electronegative difference. They share electrons equally. What is electron domain geometry and how do we predict it with Vesper? How electrons are located around the central atom. Count bonded and non-bonded and refer to Vesper theory for shape. Um, how electrons are located. So formal charge is going to be the number of valence electrons that it normally has, and then the amount that it has on that specific molecule. What is the two types of geometry? You could have electronic geometry, um, which is considered the distribution of electrons in a molecule, and molecular geometry, which is the shape of the molecule. What is bond polarity? Bond polarity, it speaks to uh, the partial charge within the molecule, how unequally shared. Yeah. What is molecular geometry? It's gonna speed up at some point. I just don't know when that is. What is molecular geometry? Um, what is molecular geometry? Um, uh, it is the geometry. It's basically the shape of the molecule. Only considers the bonding electrons to give the shape of the molecule. Okay. Um, what is electron domain? It considers the distribution of electrons around the molecule. We predict it by counting the bonding and non-bonded electrons and then referring to Vesper for the shape. What is bond polarity? It's how equally the electrons are shared. What are the characteristics of covalent compounds? In covalent compounds, a you have weaker IMFs, so you have lesser melting and boiling points. Uh, you have they don't break down into ions and they're poor conductors. It describes the energy required to break down a bond into its components, uh, like separate components into their separate gaseous atomic states. Um, when it has resonance structures, it's gonna behave like a hybrid. Sometimes it has a like a dominant resonance structure, so it's gonna behave mostly like that, but it's gonna have small properties of the others. What is a crystal lattice? An organized arrangement of ions in order to uh, minimize system energy and stabilize a compound. What are the characteristics of ionic compounds? Um, they have high melting points and boiling points. They dissolve in water and polar solvents, and they form crystal lattice structures to maximize attractive and minimize repulsive forces. A resonance structure is uh, a Lewis structure with the same connectivity and different electronic arrangement. What is molecular geometry? It considers only the shape of the atoms connected to the center atom. It doesn't consider the like non-bonded electrons or anything like that, um, or the electrons really. Oh, then okay, that's not true. I'm gonna click again just because it literally says it only considers bonding electrons, and I specifically said not even electrons. The net vector describing uh net vector. Let me get my charger before it dies, before my laptop dies, because it's honestly about to. I didn't even realize. Um, so um, what is the dipole moment? What is the dipole moment? It's gonna be the net vector. Um, Describing like the distribution of partial charge, bro. That's, I'm gonna say that's okay. So you're gonna want minimal or no formal charge. You're gonna want minimal separation between charges if they have to be there. And if you're gonna put a negative charge down, it has to be on the most electronegative one, or like prefer it to be on the most electronegative, like atom or element. What is molecular geometry? It describes the shape of a molecule. It involves only the bonding electrons. What are the two types of geometry? It can give you the molecular geometry, which is just the shape of the molecule, or the electronic geometry, which is going to be um, the distribution of electrons in a molecule. Three bonded pairs and zero lone pairs is going to be trigonal planar. Okay, I'm kind of spoiling it for myself, but I just need 1 second because, okay. So what we are gonna do, whenever I see this in the future, um, I'm gonna change the cards to say to ask for the bond angle too. Um, I didn't know it this time, but I got the question right. I'm gonna give myself hard because I would have known to say 120, or would have been my guess. Four bonding pairs and one lone pair. I just spoiled this for myself. Three, but I don't remember the name. Um, Three bonding pairs and one lone pair is always gonna be like it's like this crazy like structure where they're all leading up to one center, right? And then it just has this like balloon on top. So what ends up happening is that you end up having this like end up having this weird shape that kind of looks like trigonal pyramidal, like like trust. And the shape is gonna be the shape is not the shape. The bond angle is like less than 109.5. Okay. What is bond polarity? The net vector of the distribution of charge. Bruh. I don't, bro. That's a dipole moment. I'm glad I gave myself again because what is electron domain geometry and how do we predict it with Vesper? It describes the distribution of electrons in a molecule. We predict it with Vesper by counting the bonded and non-bonded electrons. Um, and then referring to Vesper theory to figure out the shape. I don't know if you guys could hear that. Let me. I don't. Okay. I don't. I don't think you guys could hear it. Hopefully not. But uh, associated with two bonding pairs and two lone pairs. So imagine if these all had been, we would have had we would have had something like this, right? If they were all if they were all bonding pairs, but they're not. So instead, if we have two bonding pairs and two lone pairs, and these get turned into lone pairs, it's gonna you only have two bonding pairs remaining, so this has to be bent, right? Yeah. Bent 104.5. Um okay. Again, what is bond polarity? The It describes how unequally the electrons are shared. Resonance structure is it describes a Lewis structure with the same conductivity but different arrangement of electrons. Three bonding pairs and two lone pairs. So after tetrahedral, I think is trigonal bipyramidal. Um, if you reduce trigonal bipyramidal, what it would look like fundamentally, like if you were just drawing it on a flat plane, it would look something like this. So if two of them were lone pairs, uh, how would that look? Is it gonna get rid of these two? Is it gonna get rid of these two? I think the most simple way to think about it is that it would take this one and this one, and then it would turn into, what would it turn into? What can I think of? What can I think of that it would turn into? I'm gonna guess. I'm gonna take a wild guess and say T shape. It doesn't look like it would turn into T shape, but I'm gonna guess T shape. Oh my god! Because I was just thinking, like, what if it did? What if it did take two of the opposite side ones, right? Like it took this one and this one. Then you have this like straight line, the 180, and then you have this one that's just gonna go straight down. It needs to get as far away from these as possible. It's gonna go straight down. So I don't know. I just thought about it like more like 3D. I don't know. Um, so it's gonna be 90 and 180. Okay. What is the molecular geometry associated with two bonding pairs and two lone pairs? Um, Bent 104.5. Molecular geometry associated with three bonded pairs and zero lone pairs. Trigonal planar. 120. Two bonding pairs and three lone pairs. Uh, I think. Okay. All right. My camera froze for some reason. That's strange. Okay. Two bonding pairs and three lone pairs. I think as you get lower in the like chart of which ones you're doing, it starts instead of adopting like a bent shape, it does start doing linear. So my guess is going to be linear. Yeah, you see what I'm saying? Sometimes it's just random. It's random sometimes, and of course it's gonna be 180. So when when okay, it was a guess, so I'll give myself again. When a molecule has resonance structures, which of its resonance structure will it behave like? It's gonna behave like a hybrid of all of them, except for like if it's dominant. If there's one that's dominant, it's gonna have small features of the non-dominant ones. What is the molecular geometry? Three bonding pairs and one lone pair. So it would normally have been tetrahedral. You remove one, you're gonna have um, remove one, and it's gonna be trigonal, trigonal, trigonal parameter. Oh, I didn't give the bond angle. Okay. Um, Less than 109.5. Three bonding pairs and two lone pairs. Uh, this is T-shape, 90 and 180. Dipole moment is the net vector of the distribution of partial charge. What is the molecular geometry associated with two bonding pairs and three lone pairs? Linear. What is the molecular geometry associated with five bonding pairs and no lone pairs? Trigonal bipyramidal. I'm gonna say like uh, what angles could this be? I don't know. 90, 120, and 180. What is bond polarity? Um, Bond polarity is it describes how unequally spread the charges. What is molecular geometry? What factors does it consider? Molecular geometry, it describes the shape of the molecule. It only considers the bonding electrons. What is molecular geometry associated with three bonding pairs and one lone pair? Tetrahedral to trigonal pyramidal, less than 109.5. And give you the molecular geometry and the electron geometry. Molecular geometry is the shape of the molecule. Electron geometry, it describes the distribution of electrons in the molecule. Four bonding pairs and one lone pair. So it'd be five domains. This must be a new one. Yeah, five domains. What would that be? Um, I don't think I know this. I don't think I. Oh, this might be seesaw. I think it's a seesaw. 180, 120, and 90. Um, Five bonding pairs and no one pairs trigonal bipyramidal. This is gonna be uh 90 and 120. 90, 120, 180. What is the molecular geometry associated with five bonding pairs and one lone pair? Um, uh, I don't know, bro. Square pyramidal. What is the electron geometry associated with four bonding pairs and two lone pairs? I also don't know, bro. What is the with six octahedral? That's like all 90s. Oh, 180s. What are the symmetric molecular geometries and why are they important to know? So I'm just gonna. I think it's might be all of them, bro. Linear, trigonal planar, trigonal, no, tetrahedral, trigonal bipyramidal, and octahedral. Why are they important to know? Oh, what is the molecular geometry associated with four bonding pairs and one lone pair? Um, this is seesaw. It's 90, 120, and 180. Um, it like uh it revolves around the distribution of electrons in a molecule is predicted by counting the bonding and non-bonding electrons or domains, and uh, and referring to Vesper theory to figure out the shape. Five bonding pairs is trigonal bipyramidal. Damn, I forgot about the angle. Let me put it in the question. Um, uh, okay. Two bonding pairs and two lone pairs. Bent. 104.5. Five bonding pairs and one lone pair. Uh, Square pyramidal is gonna be 90 and 180. Four bonding pairs is gonna be square planar. Is gonna be also 90 and 180. Octahedral is gonna have, I think, also 90 and 180. What are the symmetric? They're important to know because it means that the dipoles can cancel out. It's gonna be linear, trigonal planar, tetrahedral, trigonal pyramidal, or bipyramidal, and octahedral. A resonance structure is a Lewis structure with the same connectivity but different electron arrangements. Trigonal bipyramidal is going to be uh, uh, 90, 120, and 180. With polar bonds, always exhibit polarity. Um, what? Oh no. It can have polar bonds. It doesn't make the whole molecule polar. What is bond polarity? It describes how evenly shared the electrons are. What are like these are forces between separate molecules or electrostatic interactions that come from the interaction between different molecules. Three types: covalent, ionic, no, bruh. London dispersion, hydrogen bonds, and ionic. Damn. Oh my god, bro. What are hydrogen bonds? These are intermolecular forces that come as a result of electrostatic interactions between hydrogen and oxygen, nitrogen, or fluorine. And a molecule becomes stronger. How do melting and boiling points change? Um, how do melting and boiling points change? Uh, they increase. What is the molecular geometry required associated with three bonded pairs and zero lone pairs? Trigonal planar 120. Three types of, okay, so London dispersion, dipole dipole, and hydrogen bonds. Two bonded pairs, linear 180. What is the molecular geometry associated with four bonding pairs and one lone pair? Um, is there like a, there's something else? I swear I heard a voice right there, but I could be bugging. Um, that was a little odd. Please hold. Okay, that's a little weird. I don't know why that shows up on my end. I don't think that's supposed to show up there. Anyways, four bonding pairs, one lone pair. Four bonding pairs and one lone pair. Um, uh, Seesaw. 90, 120, 180. Three bonding pairs and two lone pairs. T-shaped. You're gonna have. I think it's also 90, 120, and 180, bro. Weirdly enough, actually no, I can't say that. It has to be 90 and 180 only, bro. Um, electron geometry associated with four bonding pairs and two lone pairs. Square planar is gonna be 90, 180. God damn it. My controller died. What we're gonna do instead, we're gonna do it by hand because What is the molecular geometry associated with five bonding pairs and one lone pair? It's gonna be square pyramidal. It's gonna be not still 90 and 180. Associated with two bonding pairs and two lone pairs. I think it's gonna be bent. It's gonna be like 104.5. With two bonding pairs and three lone pairs, this one's gonna be linear, so 180. Five bonding pairs and no lone pairs. Trigonal bipyramidal, it's gonna be 90, 120, 180. Octahedral is gonna be 90 and 180. With three bonding pairs and one lone pair. Uh, um, Three bonding pairs and one lone pair. It was tetrahedral, so it becomes, oh, this is trigonal pyramidal. It's gonna be less than 109.5. What are hydrogen bonds? They're strong intermolecular forces or strong electrostatic interactions that result from hydrogen bonding with a nitrogen, oxygen, or fluorine. What are intermolecular forces? Um, they're weak electrostatic interactions between different molecules. No. What are the symmetric molecular geometries? They're important to know because it means that some dipoles can cancel out. It's going to be linear, uh, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Bond polarity is a net vector of. Yo, this is incredibly loud in my ear. Is it that loud for you guys? It is. We're going to lower that. Yes. What? Sometimes like it happens every day. It's just somehow really loud. I don't even change anything, like the settings. Sometimes it's just genuinely like my volume on the computer is like a lot higher than it should be. But what is bond polarity? It describes how unequally the electrons are shared. Three types of intermolecular forces are um, three types of intermolecular forces are Uh, sorry. Hydrogen bonds, dipole, and lung dispersion. Um, what is molecular geometry with five? Uh, Square pyramidal, 90, 180. Two and two. Bent, 104.5. Associated with four and one. Um, uh, Seesaw, 90, 120, 180. Octahedral. Associated with four and two. Square planar is 90 and 180. What are hydrogen bonds? Strong electrostatic interactions or intermolecular forces resulting from hydrogen binding with nitrogen, oxygen, or fluorine. Fluorine. What is the molecular with five? Trigonal bipyramidal. It's gonna be. I think it's just. Is this like 109.5 like flat? Oh damn! Oh brother. Associated with five bonding pairs and no electrons. Um, it's gonna be trigonal. Trigonal param. Yeah, trigonal bipyramidal and no lone pairs. I like distracted myself in my head enough to forget. Um, it's gonna be 90, 120, and 180. We'll see you tomorrow, buddy. All right. Um, okay. I'm gonna load up the Jack Weston so we can do today's what's it called? Oh, today's cars passage. Okay. Okay. Uh if it's any other answer but that one, I'm gonna, I might crash out, bro. The central thrust. Is it- My fault, bro. My fault. God damn it. How does the passage integrate that they don't want to help? I'm pretty sure all the questions I got right were the easy ones. Oh, I got one of the easy ones wrong. Oh, okay. All right. So this has been a relatively short stream, uh, but at least it was another day where we pushed through. Obviously, there are going to be some days where we don't do the full 60. And like I said yesterday, there are also going to be days where we go over the 60. Um, Today was one of the days where we go under the 60. So, um, yeah. I hope that everyone has a good rest of their day, afternoon, evening, and night. And